Okay, how many of you are familiar with web? We talked about web last class, right? Everybody's okay with that?
Oh yeah.
What happens in web? What's the problem? Quick.
Weak.
Why is it weak? It's because of the IV. The initialization vector is resent, and there are only so many combinations. Once you capture all the combinations, you can break that thing. So, yeah, I have put up the slide. Do you want me to put up the slides, or we can just cover the main chapters topics? Anybody knows what's WML?
WML.
While we are getting the slide set up. Nope. You know when you have your cell phone and you watch something on the cell phone, it's using something called WML. Okay.
What's my line?
Wireless markup language. So that is what is being used. So earlier when you had your web server, which uses what? It would use the transport layer, right? And this one was using a special thing called WML. Now it had to do the encryption and decryption between the two. That is where the problem came up. Because what happened is that if from the mobile device you wanted to go to your web server, whatever you were doing on the mobile device had to go through a gateway which would translate it to the normal HTML, because this was WML. So, you know, when it did that, it would decrypt everything, even if anything was encrypted. So if somebody at that gateway could read everything that was going back and forth. So that was a big security issue. Anybody knows what was it called?
I'm sorry, I was doing two different.
We're talking of WAP protocol, WAP, Wireless Application Protocol.
Okay.
And what that does is, when you run it on a browser, on a cell phone, like you're using WML, right? And when it's getting something from a web page from a web browser, that is obviously running HTML, right?
Yeah.
So these two are not identical; they're different. So if your session was encrypted, then there used to be a device in the middle called gateway, which used to decrypt and then re-encrypt it on the other side. So that device would watch everything in clear text, because now it would decrypt it, make it into clear text, then re-encrypt. Anybody knows what this problem was called? Obviously this problem has been fixed, otherwise you wouldn't be using it. But what was the problem called? Okay, I'll leave you all to research it. It's called gap in the WAP. So GAP in the WAP, okay? So you can then Google it and see what was it. But obviously it has been fixed. It's no longer there, okay? Everybody knows WPA2 is the better one, right?
Yeah.
And what is the difference? Yeah. Now WPA2, see WPA used what they call TKIP protocol. All that it did was take the web and put a little cover over it with TKIP, and TKIP did one interesting thing, and that was dynamic rekeying. You remember in the Cisco video we showed you, there was something called dynamic rekeying. That means with every packet you could change the keys. So keys started to get changed. That was a good thing, because what happens is by the time somebody can crack it, your key is already changed. You understand? So that made it a little more secure. So after that came WPA2, which actually does what? What's the difference in WPA and WPA2?
Store authentication.
Yeah, and that uses an encryption called AES, which is a very strong encryption. It's the number one encryption that you're using for symmetry.
Great.
Pardon?
It's a government grade.
Yeah, it's a government. Government is all using AES today. Okay, so it uses an AES encryption, and that makes it much better. Okay, so that was one of the things that your thing was. Let's just go through this. Everybody's familiar with this, right? We did this part. We talked about all these three. We showed you a video on this. Everybody's familiar with WAP. We talked about the wireless application protocol, and I told you can Google gap in the WAP and see what that was about. Okay, and obviously this is the transport layer security. So at the transport layer, you're trying to put security. It does authentication, encryption, and data integrity. So all these three are the things that are done. Everybody knows integrity is done with a hashing algorithm. And somebody told me I didn't show you all what a hash was. Did I? Did I not? I didn't show you what a hash was.
Use the diagram you used in the WAN class.
I showed it in the WAN class.
It was a way better diagram than the hash diagram you used here.
Okay.
And we didn't do the hash calculator. That's the thing.
Okay, the hash calculator. We will see in the end how much time we have. I have lots of videos today, so maybe hash we'll keep for the next class. Okay. If we can get done with this, it's a lot. Okay.
Hash calculator makes it make
Okay,
sense.
we'll do that next class. Hopefully, remind me. Okay. So basically, there are many types of authentication you can do. Anonymous is what normally is done. Allows anybody to connect to the wire portal. Server authentication is that. So whenever a workstation wants to go to a server, the server will authenticate it. And then in some, you can have a two-way authentication. That means not only will the server be authenticated, the client be authenticated, the server can also be authenticated. Okay, so we know what is an access point, right? Everybody has an access. How many of you have wireless access points? Here, there's one up here.
And it's
Okay.
down.
We talked about antenna placement because antenna signals can go all over the place. So if you don't want it, you can have something called directional antennas so that you can place it. MAC filtering is there. Okay, now there used to be something called extensible authentication protocol, but it's a fairly big protocol. So they can't use the whole protocol on wireless. So they came up with something called lightweight authentication protocol. So it was LEAP. However, it's not very secure and it has been phased out by Cisco now. And they've got something called PEEP. Okay, so it's a protected extensible protocol. But again, they recommend not to use either PEEP or LEAP. There are better methods to use, and you can use those. Everybody knows what are the vulnerabilities. I want to show you some of these vulnerabilities in a video, so we'll skip some of this quickly. Everybody knows what driving, right? You can put that in your car and take it from place to place and see which are the networks that are open, and you can connect to those
We're
networks.
driving.
Yeah. What shocking used to be there earlier, they used to have closed networks and open networks. Closed used to be a circle, open used to be the opposite of the circle, like this way. So if you ever saw something like this, it was open, and if you saw this, it was closed. So you knew that there was an open network or a closed network. So people would then know that you could connect to this. But again, that's long, long gone. That was right in the beginning when people started to use. Now everybody knows that. So. Now you can get it on the internet. Now you can see everything on the internet, where access points are there, which is open, which has protection, what protection. Your whole map is available on the internet. So, okay, there is something called event twin attack, and I'm going to show you a video on that. Everybody knows what's a rogue access point, right? You can put an access point in another area, and that's a rogue access point, and it's not authorized. Right? For example, a college network, if you put an access point and connect to it directly, that is wrong, because you can connect the network of the college through the rogue access point to go out to the internet. So then you are bypassing the firewall. Then there's no meaning of the firewall. Are you understanding? If I could connect my college network to the internet without going through the firewall, then there's no point in having a firewall. So that's not allowed. And blue jacking, blue snuffing, both are Bluetooth things. This is when you get a whole lot of junk, and this is when somebody can take control of your device. So that's even worse. Okay. Okay, so that is all that is there in this slide.